friends, welcome to LogicHeap. In this tutorial, we are going to see how we can traverse binary trees. Traversal, as we know, it means going through each node one by one. So let's check it out. There are two types of traversal, depth first traversal and breadth first traversal. So what is depth first traversal? As the name implies, in this we go as deep as possible in one path. Once it is done, we'll backtrack and we'll check out the next path. Again, in the next path, we'll go as deep as possible and then again we'll backtrack. So that's how we firstly explore the depth in depth first traversals. If that doesn't make sense, let's consider it with an example. Suppose you have a binary tree having these elements as 10, 20, 30, 40, 50 and 60. Now we want to traverse this binary tree using depth first method. So any traversal, we always start with a root. 10 is a root node and it contains references to the left node and the right node. So in the left node, we have the reference to 20 and in the right node, we have reference to 30. Now let's say it has started exploring the left path. Then we'll move to 20. From 20 again, there are two paths. We'll choose one. We chose the left path. So then we move to 40. So this is the path that we have traversed, 10, 20 and 40. Since there are no further nodes after 40, we'll track back. So from 40, then we'll come to 20. From 20, see, we have already explored 40, so we'll choose the other path, which is the right reference, and then we'll move to 50. So in the action 2, we explored the second path. Now once you have accessed this 50 as well, you'll backtrack to 20. So from 20, both the paths have been covered. We'll move to 10. So we have backtracked till 10. Then the complete left subtree of 10 now have been traversed. So we'll move to the right side. So from 10, we'll move to 30. And from 30, we chose the path to 60. So 10, 30 and 60. So these were the all possible paths that we have traversed. For each path, we went till the depth, then we backtracked and chose the other path and so on. This is called depth first traversals. So there are three types of traversal under depth first traversal. Let's consider the example that in traversal, what I want to do is every time when I traverse a node, I want to print its value. Whatever is in its data, I want to print that value. So that can be done in three ways. Firstly, when you start this traversal, firstly you will print its value and then you will move to its left subtree and then its right subtree. So firstly you'll print the value of 10 and then you are moving to the left and then to the right. This is called preorder traversal. In the preorder traversal, firstly you access the value of root, then move to left and then to the right. In the inorder traversal, firstly you go to your left subtree, print all the values of your left subtree, and then when you are backtracking, then you come to the root again. So you'll print root and then you move to the right subtree. So this is inorder traversal. In the postorder traversal, you'll first traverse your left subtree, then your right subtree, and finally the root. So once your complete backtracking is done, you will move back to the root. That time you print it. So that's the difference. When you are actually accessing your value at the start of the traversal, during the backtracking, at the end of the backtracking, makes three types of traversals, which is inorder, preorder, and postorder. Let's check the code, how we'll implement those traversals one by one. Let's start with the inorder traversal. So we'll write a very simple, very intuitive recursive algorithm here for inorder traversal. If you're not clear with recursion, even writing this function will help you to understand recursion better. So don't worry if you don't understand recursion. It is very simple to understand. So every time when we start, we always start with a root. So we'll get a root from the user. Let's name this function as inorder traversal. So the name is inorder underscore traversal. We'll ask the user to get us the root. So in the current example, a root is the node having 10. Now what inorder traversal says? Firstly print the left subtree, then the root and then the right subtree. So the node 10 should say, please don't print me or don't traverse me currently. go to my left tree first, left subtree first, and then come to me. So we should again call the in-order traversal. But think carefully, what should we pass inside this in-order traversal? It is saying don't print me, print the left node of me. This is the left subtree for 10 and its reference is kept inside the root dot left. We'll say root dot left. So see, this is recursion calling the same function again, but this time the argument I have passed is root dot left. Now again it will call the same function in order traversal, but now root has become root dot left. So now we are calling in order traversal again, but in this root, in this method, we have come with the value 20. So now for the 20, when you run this method, it will say don't print me currently, go to my left subtree. This is the left subtree for 20. So this is the left subtree and its reference is in root dot left. Currently root is 20, so root dot left has the reference to 40. So again we'll call the same method, this time in order traversal root dot left, so it contains the reference to 40. Now we'll call in order traversal again, but this time root root has been changed to the element having the data as 40. So what 40 is going to say? As soon as we'll enter in this function, we'll say don't print me, go to the root dot left. So again we'll try to search the left of it. But what does the root dot left contains this time? In the case of 40, the root dot left contains none because there's no further node after it. What should we do when we get the root as none? We should not do anything, we should simply return because we don't have anything to traverse here, print here. So I'm adding one more condition here, which would be the exit condition from this recursion. This recursion should stop somewhere. So see the condition that I'm going to write. If root equals to none, simply return from here. So now I've modified this function. Now as soon as you get root equals to none, just return from there. So we'll return to 40. Now we have traversed in a way its left subtree. So this is the time we should print the root. So let's print root dot data. So in this example, now we have printed 40. So currently what all we have printed? Just 40. Let's just write it down here. We have traversed 40. So from 40, now since we have traversed the root, we should move to its right subtree. So we'll go to its right subtree. We have not written this code here. Let's write it in order traversal for the right subtree. So what should we pass here? Root dot right. So we went to its right reference, which is none because there's no further node here. When we run this method with none, with argument is none, what it does, it returns. We have traversed both the left and right subtree, so we'll backtrack to 20. In case of 20, we have already traversed its left subtree, so we'll print 20 now. Now, left subtree is done, 20 is done, we'll move to its right subtree. We'll move to 50. So this node will then again run the same method with root dot left. It will return none. Then it will print 50. Then it will move to its right subtree, which is again none. So we'll come back to 20. Now we have traversed left subtree of 20, its data, and right subtree as well. Once the complete traversal is done, we'll again backtrack to 10. Now, since the complete left subtree of 10 is traversed, we'll print 10. We'll move to its right subtree. Now we come to 30. With 30, it will say, don't traverse me. Firstly, go to my left subtree. So this is the left subtree of 30. 60 will say, don't traverse me, go to my left, which is none. So we'll come back, then we'll print 60. Then we'll go to its right subtree, which is none. So we'll move back to 30. Now, for the 30, its left subtree traversal is done. So we'll print 30 and then we'll come back to 10. So this is the complete method how we do the in order traversal. Firstly, we go to left subtree of each node, then we'll backtrack, then we'll print the root, Then we'll move to its right subtree. This is in order traversal, and that's how we printed its values. Firstly 40, then 20, 50, 10, 60, and 30. You can see here, that's how we'll write the code in Python. Next comes the pre-order traversal. Firstly, we traverse the root value, we access the root value, and then we move to its left subtree and then the right subtree. Now check if you're getting this intuition how you'll write the pre-order traversal. There is a single line of change from what we have written in the in-order traversal. So in the in-order traversal, firstly we were traversing the left subtree, then we were printing the data, and then we were traversing the right of it. In case of pre-order traversal, firstly print this data, then move to the left subtree and then move to the right subtree. So in the pre-order traversal, I'm not going to show you the complete stack of functions. In fact, I'm just going to show you what would be the final result. As soon as you get the root, just print it. So the first value that will get printed is 10. After that, you move to its left subtree. In the left subtree, firstly you encounter this 20. You will print it. Now from 20, again you will move to its left. So in the left subtree of 20, you have 40. Let's print 40. Now again you will try to move to its left, but it's none. So we'll return from here. Again come back to 40 and then we'll go to its right subtree, which will give you none again. Come back to 40 and then backtrack to 20. And then move to its right subtree. Then you'll, as soon as you reach to any node, what you do? Firstly you print it. So what you'll write here? 50. You'll try to go to its left, none, so you'll return. Then you'll try to go to its right, none, so you'll return. From there, you'll again come back to 20, you'll come back to 10. Root element is printed, left subtree is printed, we'll move to the right subtree. This is the right subtree of 10. Here, you reach to 30, print it. Now, from 30, you'll go to its left, which is 60. Now, print 60. You'll try to go to left and right of it, both are none, you will return back to 60. Then you will move to 30. Since there's nothing in the right, you'll try to go to the right of 30, but there's nothing, so you'll again move to 10. So that's how your traversal is done. See, the order of the elements is completely different from what you got in the in order. Here the result is 10, 20, 40, 50, 30, and 60. So this is your pre-order traversal. If you want to see the code, this is the code. See, the only change in this method, you are going to print it, then you are traversing the left subtree, and then you are traversing the right subtree. Now it is like a cakewalk for you to write the post order traversal. Don't see the screen, just write the code, just try to do the dry run. So again, in this traversal, you will start with 10. But what is the post order traversal? Firstly, you go to the left subtree, then you go to the right subtree, and then the root. So for 10, this is your left subtree. You come to 20 now. From 20, what is its left subtree? 40. So you come to 40. Then what is its left subtree? None. So you'll return to 40, but you'll not print it. Then you'll go to the right subtree. There's none, so you'll return. Now you'll print 40. So first value you got is 40. Now you backtrack to 20. But will you print it now? No. Firstly, you'll move to right subtree, so which is 50. Here also you'll first try to reach to the left of it, which is none. So you'll return to 50, then you'll try to move to the right subtree of it, which is again none. So you'll move to 50 again. Now you'll print it because you have traversed both the left and right subtrees of it. So you'll print 50. Now since you have traversed both the left subtree and right subtree of 20, so this is the time when you will print 20. Now this traversal is done, you will move to 10. But since you have not traversed the right subtree of 10, you will not print it. Let's come to the right subtree of it. So 30 is the first element here, but you will not print it. You will move to the left subtree of it, which is 60. So you come to 60 and here both left and right subtrees are null. So then you will print 60 here. Then you will move back to 30. but you cannot print it until you traverse to its right. Since right is none, so you'll move back to 30 and now you'll print it. Now the right subtree traversal of 10 is done, so we'll move back to 10. And now since left and right subtree are done, you'll print 10. So this is your post order traversal. If you want to see its code, this is its code. Just see that print we have kept at the end. And link for the same is in the description box. Do check it out.
Thank you so much, guys, for tuning into LogicHeap. If you like this video, please don't forget to like, share, and subscribe.